All right, guys, good afternoon or good morning, depending on when you're watching this video. Today we are going to be making a foldable. So here I've got a piece of red paper. You do not need red paper. You can do this on notebook paper. You can do this on whatever kind of paper you've got. So what we're gonna do is we're gonna go ahead and start by hot dog folding our piece of paper. And I am gonna leave a little strip of paper here out. That way we can write on it. So we're going to go ahead and fold our piece of paper like this. Over here on the side, we are going to write the real number system. The real number system. Right, like that. You can also go ahead and write your name. That way, if ever you bring it to school or anything like that, you'll have it there. And then I would love for you also to write your bell number. You are going to be turning this in once we're done, so it's going to make it a little easier for me to know whose paper is whose. I left it blank because I might give this to a student or anything like that. So what we're going to go ahead and do is we are going to make this into multiple sections. There are 5 sections of the real number system. So what we're first going to do is fold our piece of paper top to bottom to make a nice little small square like this. We're going to open it back up, and now we've got a top and a bottom half. We're going to look at the bottom half first. On the bottom half, we're going to take the bottom and we're going to go up to the middle. Now remember, you can absolutely pause my videos. If you need me to go a little bit slower, you can pause them. So we're going to bring the bottom up to the top here. So you've got bottom to top. So now you should have 2 sections on the bottom. On the top section, we're going to do a tri-fold. So we're going to make 3 sections. The way that you do that, I'm going to flip it upside down so it's down here at the bottom, is you're going to fold like this to where you think about halfway between the middle point and the bottom is. So I'm going to fold it like this, and then I'm going to fold it one more time. If your sections are not perfect, that's totally fine. We're just using this as a guide for where to cut, okay? So you should have 1, 2, 3, 4, 5 sections, and the bottom 2 should be a little bit bigger. We're going to go ahead and take our scissors, and we are going to cut up those folded lines, and we are only cutting the top flap up until the middle fold. So we're cutting right like that. So when we're done, we're going to have a nice little foldable flip book thing with 5 little flaps and windows. Oops. All right, so we've got 5 sections here. Now we're going to start at the top, and we are going to label each of these sections with our subsets of the real number system. The smallest subset that we talk about are our natural numbers. So I'm going to go ahead and write natural. The next subset that we talk about is our whole numbers. After whole numbers, we talk about our integers. Then we talk about our rational numbers. And last but not least are our irrational numbers. So those are our 5 subsets of the real number system. Remember, all of these numbers are real numbers, so we can talk about all of them as being real numbers. I am going to take a black marker here, and I'm going to go ahead and cut this in half. So I'm going to draw a dark black line here. And the reason I'm drawing a dark black line here is so that way I remember that rational numbers and irrational numbers are different. Okay, so I got a nice dark black line here because you cannot be a rational number and an irrational number at the same time. So I'm going to go ahead and open up my foldable to my first section, which is going to be those natural numbers. One thing that I like to do when I make a foldable is I like to clearly define where my fold lines are. And the reason I like to do that is so that way if I have multiple sections open, I know what section is what. So I'm going to open that natural numbers back up, and I've got 2 sections here. On this side, we're going to write some examples, and on this side, we're going to write the definition. So let's talk about our examples of natural numbers first, or our definition first. So natural numbers are also called our counting numbers. So natural numbers, also known as AKA counting numbers. Sorry if you guys can hear my kiddo in the background. He's talking on his class. All right, so next so our natural numbers, they are going to start at 1. And we do not include 0. Do not include 0. Yeah. We're going to talk about that in just a second where we put zeros. So we're going to start to 1 and it goes to infinity. That's what that symbol means. So starts at 1 and goes to infinity. Looking at this side, some examples. We're going to start at 1, 2, 3, 4, 5, and then we're going to write dot, 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 because remember, that means it goes on like this. It follows the pattern. Some more specific examples, maybe you want to put 1 million, because 1 million is a natural number. We could count to 1 million. It would take a while, but we could do it. We could count to 87,000. We could count to 3,459,876. We could count to those numbers. Wouldn't be fun, but we could do it. Let's talk about whole numbers now. Whole numbers. So again, I'm going to define my boxes so I know where whole numbers is. Our whole numbers are the counting numbers plus 0. So it's those counting numbers plus 0. So this is where we include 0. So this is going to go from 0 to infinity. 0 to infinity. So again, we'll start over here and we're going to start at 0, 1, 2, 3, 4, and it's going to go on forever. The big one here is 0. We could write all the same examples that we did for natural numbers. So I'm going to do that really quickly. 1 million. We'll do 90,000 this time. And we'll go with 1,467,321,000. And we'll just end with 3 zeros. We could count to those numbers and we could start at 0. Let's talk about integers next. Integers are going to be the set of whole numbers. So we're going to make our boxes again. Make our clearly defined boxes. So integers are whole numbers and their opposites. And don't forget 0 is included, because a lot of people forget 0 when they talk about integers because there's no opposite of 0. Just as a reminder, there are no fractions or decimals. So just because a fraction is negative does not make it an integer. So be careful. No fractions, no decimals. So let's talk about some examples over here. We can talk about 0 being in the middle, and then we can put 1, 2, 3, 4, and it'll keep on going like that. And we can talk about their opposites, -1, -2, -3, -4, and it can go on forever in that direction. We can talk about some specific examples. Maybe when you want to talk about like -7, -1 million, any of the previous numbers and their opposites. Remember, -1 million is an integer, but so is +1 million. The positive versions are integers too. Only thing special about integers is now we get to include negatives. All the other ones are still integers, just we're including negatives. Now let's go ahead and talk about our rational numbers. Rational numbers is our biggest category we're going to talk about so far. Those are our rational numbers. CLB, the one that's your name. All right, so rational numbers, this is where most fractions and decimals are going to go. So most decimals, all fractions. We have two types of decimals that are going to be in this category. So I'm going to cut this in half like this. The first kind is repeating decimals. These are decimals that go on forever. And then we have terminating decimals. Terminating decimals. So we've got decimals that go on forever and decimals that terminate, and then all fractions. All right, so let's go and look at some examples of some rational numbers. We've got something like this where it's 0.21212121, and then you might see a dot, dot, dot like this. They also can abbreviate it like this, 0.21 repeating. So if you see it either of these ways, this is a repeating decimal. You might see it in a pattern, or you might see it with the line over its head. Both of those mean the same thing. We could talk about a decimal that ends like 3.14, not 3.1415 dot, dot, dot. We're just talking about 3.14. So that one is a terminating decimal, okay? We could talk about a fraction like 7/8. We could also talk about any of the numbers we previously talked about, like -1, -7, 0, +2, 4.5, anything like that. We can talk about decimals being negative. So we could write 3.14 or -3.14. We also talk about fractions being negative. So we could write something like this where it'd be -7/8. You might also see something that needs to be simplified. So maybe you've got 25 over 5. When I divide 25 by 5, that's going to give me 5. So because it simplifies to 5, I know that it's a rational number, and it would also go all the way up to natural numbers. If you had something like this where it was the square root of 36, I would know that that simplifies to 6. And again, that would go all the way up to natural numbers. Just as a reminder, a repeating decimal and a terminating decimal. Let's talk about what each of those means. So a repeating decimal is one that goes on forever. So that might be like 0.16 repeating, or it could be 0.3333 dot, dot, dot. A terminating decimal is one that we can see the end of. So 0.5 or 0.123 or anything like those. Plenty of examples of rational numbers because it's one of the largest groups that we talk about. The other group that we're going to talk about is irrational. Remember, there's a dark black line here. I'm going to make it even bolder so you guys can see it a little better. This dark black line here reminds us that there is no way for a number to be rational and irrational at the same time. Those are two different groups of numbers here. So let's look at irrational. Let's look at irrational. So irrational are the crazy decimals. If you've ever heard your mom talk about something being irrational, she's ever called you, she said, "You're being irrational right now." It means crazy. It means hard to deal with, any of those words. So these are your crazy decimals. The only thing in this group are the crazy decimals. That means the non-repeating, they don't repeat, and the non-terminating. They don't repeat and they don't terminate. So we talked about what repeating and terminating means. So we know if they don't do this, then they are not crazy decimals. Just a reminder, there are no fractions here. If you get a fraction, it is automatically rational. No fractions and no whole numbers. So it's not going to be anything pretty like 7. That would not go here. We're looking for the ugly, crazy decimals. So the ugly, crazy decimals might be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, dot, dot, dot. Maybe you'll see something like this where it'll be 10.10, 10, 10, 11, 12, 13, dot, dot, dot. That's a crazy decimal that goes on forever. Maybe you'll see a square root of a non-perfect square. We don't know what the square root of 11 is off the top of our head, so that is an irrational number. Maybe you'll see the pi symbol. Maybe you'll see them write it out like this: 3.141592 dot dot dot. That means it is non-ending. We could give examples all day of those crazy decimals, but remember, it's whatever is non-repeating and non-terminating. All right, so you should have made your foldable. Don't forget, you need to turn it in on your next screen. See you there.